right, today we're going to be looking at multiplying rationals, that's the decimal version of rational numbers, and doing some applications with decimals. If you saw our last video where we were just teaching the basics of how to multiply decimals with each other, this is a little more advanced a technique. We'll start with this question here. Suppose we wanted to do decimal 7 times 2.4. One thing we can do is think of this as 7 times 24. There's a couple of mental math skills we could use to figure out what 7 times 24 is without grabbing a calculator. Namely, think of it as 7 times 20 plus 7 times 4, which would give us 140 plus 28, or 168. So now that we know that 7 times 24 is 168, we can now go back to our original problem, which again was 0.7 times 2.4, and realize that the answer is going to involve the same digits, 1, 6, and 8, but look at the difference between this question and this question. It's going to involve 1, 6, 8, but the 7 has become 0.7. In other words, it's become 10 times smaller. The 24 has become 2.4, also 10 times smaller. So if this is 10 times smaller, and this is also 10 times smaller, my conclusion should be 100 times smaller. So decimal 7 times 2.4 will be 1.68. And always when you're doing these questions, ask yourself, is this reasonable? Well, this is less than 1 groups of a number slightly bigger than 2. So if I had one group of 2.4, I'd get exactly 2.4. It makes sense that my answer is just a little less. With this reasoning in mind, I could now solve any question that involved 7 times 24 equals 168. Like, for example, 700 times 24,000. No problem. It's still going to involve a 1, 6, 8. But this time it's going to need 10, 100, 1,000, 10,000, 100 times, 100,000 times, sorry. A little bit out of room there, sorry. So my final answer is going to be 16,800,000. We could also do something like, say, decimal 07 times decimal 024. Again, I know my answer will involve 168. But this time, the number has to be 10, 100, 1,000, 10,000, 100,000 times smaller, which would mean I'd move the decimal from the end of the 8 to 1, 2, 3, 4, 5 places to the left. So the decimal would go 1, 2, 3, 4, 5 places to the left. Final answer, decimal 00168. Let's try another one. Suppose we're looking at decimal 41 times 2.5. Again, I think 41 times 25. And I think of that as 40 times 25 plus another 1 group of 25. 4 25s makes 100, so this makes 1,000 and 25. Now that I know that number, I know that the answer to this question involves the same digits, but the answer has to involve the same number of decimal places. 10 times smaller, 100 times smaller, 1,000 times smaller. So the final answer is there. Again, a quick check. Does this make reasonable sense? Well, that's less than half of 2.5, and that's less than half of 2.5.